Let's explain transfer encoding, chunked. In simple terms, it's a way for a web server to send data to a client in smaller, manageable chunks instead of sending the entire file all at once. This is especially useful when the server doesn't know the total size of the data beforehand, like when streaming a live video or uploading a file of unknown size. 1. Imagine trying to send a massive file. It would be inefficient to send the whole thing as one giant packet. Chunked encoding breaks this up. 2. Each chunk of data includes its size in hexadecimal, allowing the client to easily understand how much data to expect in each part. 3. After the last chunk, a special 0 inches, 0 chunk signals the end of the transmission, letting the client know that all the data has arrived. 4. This approach makes things more efficient, because the server doesn't have to wait until the entire file is ready to start sending data. It can send data as soon as it's available. 5. The client can then start processing and displaying the data as it's received, resulting in a smoother and more responsive user experience, particularly useful for streaming applications. 6. Consider live streaming. The server doesn't know the final size of the stream. It's constantly generating new data. Chunked encoding makes this possible by sending short segments continuously. 7. Importantly, the client receives data in chunks, assembles them, and interprets them as a complete response. 8. It's also important to note that chunked encoding is a mechanism for transferring data and is independent of the HTTP protocol's overall structure. It only dictates how the message body is sent. 9. This flexibility improves efficiency and scalability for web servers, allowing them to handle requests more effectively, particularly during times of high traffic. 10. Lastly, while chunked transfer encoding is generally preferred for unknown size data, it's important to remember that it adds some overhead because each chunk requires its size header. However, the benefits of flexibility and efficient streaming outweigh the small overhead in most